All right, so we're going to work on Unit 2. Hopefully this unit will, the videos will go a lot better than the last one. So keep your fingers crossed. All right, Unit 2. First thing we're going to do is solving for an indicated variable. This is really important, especially once you get into science. If you have a formula that you're using and you're trying to fill in certain values and then solve for the missing value, you need to be able to solve an equation regardless of which one you're missing. So basically, whenever we're solving, that means to isolate the variable. So whatever we're solving for needs to get by itself on one side. And then otherwise, we would do what our normal steps would be for any equation. So looking at example number 1, let's see here. I'm borrowing another camera. So, all right, we're going to take this, which is slope-intercept form, and we're going to solve for x. So what that means is that we want to get the x by itself. So the first thing we would need to do would be to subtract 16 from both sides. So when we do that, we would end up with y minus 16 equals negative 4x. Again, we're trying to isolate the x. So to get rid of the negative 4, we would divide both sides by negative 4. So x is going to equal y minus 16 over negative 4. And there are a few other variations. We could split that up. We cannot reduce this as is, because the way this works is if we're going to reduce anything, we have to be able to reduce everything. So for our purposes here, that is an acceptable solution. All right, number 2, we are going to solve for the length. So again, let's try to get this zoomed in a little bit. So we want to get L by itself. So if we were doing a normal problem, there are a few things we can do, but probably what you guys would do first would be to distribute the 2. So P equals 2L plus 2W. We want to get L by itself, so we need to subtract 2W from both sides, so it's gone over there. So P minus 2W equals 2L. And then divide both sides by 2 to get the L by itself. So L would be P minus 2W over 2. And again, we could only cancel those if we had a 2 over here to cancel with as well. So since we don't, it stays as is. All right, the next topic we are going to work on is solving systems of equations. This is a review from Math 8, so we're going to go pretty quickly, and I have one example of each of these. So when we are solving by graphing, basically what we're going to do is graph the 2 lines on the same coordinate plane, and then we're going to look for where the 2 lines meet. If we have parallel lines, then the answer would be that there is no solution. And coincidental lines are lines that are the same, like what a coincidence, it's the same. And they have infinitely many solutions. All right, so moving on to example number 3. First line, y equals 2x plus 8. So that is in slope-intercept form, and just to color code, I'm going to do that one in purple. So we start with the 8. 2, 3, 4, 5, 6, 7, 8. And then the slope is 2 and it's positive, so our line needs to go this direction. So I could go up 2 over 1, I don't have space. So I'm going to go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, which is basically the same thing. And let's see, there's the first line. All right, now I am going to do the second line, but I need to solve for y with the way that I want to graph with slope-intercept form. So I need to subtract 3x from both sides, so 3x plus 2, and then divide everything by 2. So divide everything by 2. So y equals negative 3/2 x plus 1. So for this problem, we're going to start at the 1 on the y-axis. And then our slope is negative, which means we need to head this direction. So it looks like we're going to go up 3, left 2, and it lands right there. Up 3, left 2, or we could go down 3 and right 2. But we end up with that for our line. So our 2 points met right here. And that looks like negative 2, 1, 2, 3, 4. Negative 2, 4 is where the 2 lines met. Did I count right? 1, 2, 3, 4. Yep. So negative 2, 4 is our solution. All right, next up, elimination. So I think a lot of people like elimination the best of the 3 ways, but for elimination, we want to get our equations in standard form, which is when x and y are on the same side, and then we use the inverses to cancel each other out. So they have to be the same number but opposite sign. And then we can cancel that variable out, solve from there, and then take our first answer, fill it back in. So I think all this will make sense in just a second. So when I look at this situation, I'm seeing right here, if I multiplied this top equation by a 2, I would be able to eliminate the x's. So this one doesn't change, but this equation is now going to be negative 6x plus 6y equals negative 18. So now when I combine these lines together, the x's are going to cancel. So I'm left with 8y equals negative 16. Divide both sides by 8, so y is negative 2. So now that I know that y is negative 2, I'm going to go back in here and fill it in. I'm going to use the bottom one. So 6x, if I fill in a negative 2 right here, that's going to make that a minus 4 equals 2. So now if I solve for x, we're going to add 4 to both sides, divide both sides by 6. So I know that these 2 lines would meet at the point 1, negative 2. All right, substitution. This is what I always like to call clouds and rainbows, which I know is just so goofy, but it's a good way, and it totally looks like it, I think. But what's going to happen is you need to solve one of the equations for one of the variables, and this one's already done for us. So we already know what y equals. Y is x plus 3. So then what we're going to do is substitute, which means plug in. So since y is x plus 3, I'm going to go down here and fill it in. So I have 3x minus, this is where our cloud has blown in there and it's covering up the y, equals 5. And then inside our cloud, we have x plus 3. So now the rainbows come in because we need to distribute that, and we need to distribute that. So we have 3x, which is the original. So 3x, and then minus x when we distribute there, and then, whoops, minus 3 when we distribute the negative there, and then it is equal to 5. So now we can solve. So 3x minus x, those are on the same side, so that's 2x minus 3 equals 5. So add 3, and 2x equals 8. Divide by 2, and x is 4. All right, so now I know that x is 4, so then we need to figure out what y is. And we know that y is x plus 3. So if y is x plus 3, then that means that y is 7. So these 2 lines met at the point 4, 7. All right, a way to check, or if you had a multiplication problem, you could always just take those numbers right there. The 4 is the x, the 7 is the y, and fill it in. So if we put 4 here, that would be 12 minus 7. 12 minus 7 is 5. So that's a way, if it was a multiple choice question, you could actually avoid using the actual method and just fill in your answers. All right, next one. We're going to write the systems of inequality, or sorry, equations. Looking at the next one. So what that means is that we have to translate our word problem into 2 equations because we need a system, which is 2 or more equations. And then we can use graphing, elimination, or substitution to solve. So it's our choice after that. All right. Number 6, a store sold 32 pairs of jeans for a total of $1,050. Brand A sold for $30. Brand B sold for $35. So how many of brand A were sold? So what we know is that we sold a total. So if we added up the brand A and the brand B, we sold 32 pairs of jeans. And we know brand A was worth $30 and brand B was worth $35, and we made $1,050. All right, so here you could decide what you want to do. I would probably eliminate. It says how many of brand A were sold, so I would use elimination and cancel the B's out. So I would multiply this line right here by a negative 35 to cancel those, and then you could go on and solve for them. Just for time, I think all we really probably need to do is just practice the setup. All right, next one. Michael loves to go to the movies. The movie ticket is $6 if he attends a matinee, and it is $8 if he sees an evening show. He spent a total of $86 on 12 movies. So how many evening movies did he attend? So first we're going to put all the money together. So it's $6 if he attends a matinee, which means during the day before 6 o'clock. And it costs $8 if he sees an evening show. And he spent a total of $86. So all of that has to do with money right there. Now we know he saw 12 shows. So if we just add up how many daytime movies and how many evening movies he saw, it would equal 12. So there are our 2 equations. Again, I like elimination. So how many evening movies? Since I want to know how many evening movies they attended, I'd probably cancel the M's for the matinee. So I would multiply this line by negative 6 to get those to cancel, and then you could go on and solve from there. All right, I'm going to end this video now so that we have enough time and pick up on the next video with the inequalities.